McPhee. I'm president of Sullivan-Palatek, Inc. and Sullivan Air Compressors. We're talking about the Department of Energy's regulation of rotary screw air compressors. I've been involved in this since the beginning, both on the behalf of our company and the Compressed Air and Gas Institute, and I have a lot of the history of what's going on. The regulation is set to go in effect in about 15 months, and it will affect performance ratings on rotary screw compressors. The biggest part of the impact is that it's going to take some of the less efficient compressors off the market or anything that can't be tested. It could have some impact also on companies that make small volume customized machines. So if we look at what isentropic efficiency is, KGI has been reporting a standard. We've had data sheets for about 15 years that had a uniform way that all manufacturers would report the performance of their air compressor, and it was reported in kilowatt drawn per 100 CFM of compressed air. And it could have been reported at different pressures. That made it somewhat confusing to compare data sheets at certain times. The federal government decided to use a slightly different standard, which is known as isentropic efficiency. And there's a theoretical standard known that can be done by math to figure out how much energy it's going to take to compress a certain flow of air to a certain pressure. So once we have the theoretical, we test the average power input of the air compressor, and then we measure it as a percentage of what the ideal conditions would be. And then we rate the air compressor at the discharge pressure, which it's the highest amount the compressor is capable of operating at. This is a little history of the regulatory process. It hasn't been very fast, as you can see, but it started in 2013. And the Department of Energy announced its intention to regulate air compressors from 1 to 500 horsepower. There was a lot of concern about that. That got members of Compressed Air and Gas Institute a little bit more cohesive, and we began working as a group. And we had information going back and forth between the consultants at the Department of Energy and our industry association. We made comments on things. There was an opportunity in 2014 to bring consultants to our plants. We brought the consultants to the Sullivan plant and to the Sullivan-Palatek plant. They went to several other manufacturers too, trying to learn a little bit more how they could place a regulation on the industry. In 2016 of May, the DOE came out with their notice of proposed regulations at that point. At that time, they cut the scope of the regulation. They decided that the piston machines wouldn't really be easily regulated, and the scope was to go from 10 horsepower to 200 horsepower on rotary screw compressors. In June of 2016, there was a public meeting which I attended with about 10 other members of Compressed Air and Gas Institute. We had 9.5 hours to listen to the presentation of the Department of Energy. They obviously had a lot of confusion, but it was a good chance for the manufacturers to have some input on what they did. At this meeting, there were also advocates from the energy industry, and they advocate to regulate everything. So we had a lot of people telling the Department of Energy they needed to regulate more. We were looking for less, and we were looking for a lot of clarification on things, on what would be regulated, what wouldn't be, even in the sizes. Within a few months, we were all able to submit public comments, and KGI jointly did a thing, and then several of the companies, including ours, issued our public comments. At the end of 2016, in December, the department issued its final rule, and it has to be placed in the Federal Register to be effective. So there was a little bit of a waiting period, and it came in two parts. There was a test procedure and a standards procedure, each of them about 300 pages long of regulations. By mid-January, the test procedure got put into the Federal Register, and we had 5 years to comply, but the standard had not been placed in the Federal Register yet. And then we had a change of administrations, and the first thing Trump did the day he was in office was he blocked any new regulations going in the Federal Register. So as a result, these standards were delayed, and it went through a court system. Several states filed lawsuits, and it was almost 4 years before the regulation actually got placed in the Federal Register. The rule is the date it's placed in the Federal Register, it goes into effect 5 years later. So that's how we got this big disconnect. In January of 19, the the California Energy Commission decided to adopt the rule, and so they put it in place with a 3-year delay, and they made it effective January of 2022. So it's already in effect in California. It's pretty much identical to the federal standard. And any company that sells in California, they must register a test facility with the California Energy Commission, and they got to list all the models and certain data for the machines that are sold there. Beyond that, the full Department of Energy rule will be in place nationwide in January of 2025. The scope of coverage, it's rotary air compressors only and lubricated only, operated by brushless motor. All this is in the Department of Energy's standard document, and they've had webinar documents that show it. It covers machines that have a pressure greater than or equal to 75 psi, but they're anything over 200 psi is exempt. The full low flow rate is greater than 35 CFM or less than or equal to 1250 CFM or with a 10 or 200 horsepower motor. But on the high end, you can see some machines at 250 horsepower or bigger sometimes being covered by the flow rate. One of the things we were able to get the DOE to do was to define what they were going to cover, because as we all know, compressor systems are very complex. So they came up with a definition of what the basic model equipment is. And I'm not going to go through all these, they're in the list, but they, you know, the driver, the bare air compressor, the separator tank, all the piping that goes through it. Eventually you go out through the discharge valve, and then there will be a separator tank at the end, and all those are part of the basic machine that has to be covered. There are items that are not covered. So if a company wants to put an integral dryer, they're going to have a pressure loss. If the filters will result in a pressure loss, which is loss of flow. So these things are not covered. And the company, even a tank or an enclosure, the companies, they test the basic machine, then they can put these things on, and it doesn't require additional testing. But it will require, as the models are different, just a basic registration with the federal government and a description of what the add-ons are. This is some of the formula, and I'm not going to go through and explain what all this is to you, but this is what develops the standard that we have. And so there's a nice little regression curve here for the isotropic efficiency, and then they come up with the minimum, the standard that you have in a percentage. And we have one standard that is for the regular rotary fixed speed compressors. Then we have another one that goes for the variable speed compressors. And then there's a little bit tougher standard if you have a water-cooled compressor, and you can see it by some of the constants that they put in the formula. And then a rotary variable speed machine with a water-cooled also is covered. Every machine is considered different running at, as you mentioned, full load pressure. So we are required to do tests on machines. If it runs at 100 horsepower, then we got the same horsepower machine, pretty much the same machine, but it's running at 125 psi. Now it's a different machine. 150 is a different, 175 is different. So we could have 4 or 5 variations within the pressure range that we have to test, and each one's considered a different machine. So it's done at every horsepower, and if it's done with a variable speed drive, we've got to go through the same thing. And if you want to make them water cooled or unwater cooled or water cooled, either way, all those are considered different machines. So manufacturers have a responsibility to test possibly hundreds of models. This shows a little bit about how the curve goes, and it's a much lower isentropic efficiency as the flow goes down to about 35, and it's in the mid-50s. You got to beat that standard. And as you get into the higher pressures or higher flows, it gets up to about 74-75% before you peak out. My impression is that the lower horsepowers are easier to meet on the standard, and the higher horsepowers are a little bit harder. There's another thing that the Department of Energy added that was a little twist. So the KGI members have always entered their flow, and then we have our machines tested and validated down in Plano, Texas, at the one certified test facility that the industry uses. And we're allowed a 5% tolerance if we miss. And companies, if they were doing it fairly, they would at least put their average in. But the Department of Energy wants to be sure that no machine is put into commerce within a 95% confidence level. And so we have to go through the math, and we have to test at least 2 machines in each size. And then we divide, after going through the formula of the 95% confidence limit, which I'm not going to go through here because that's a statistics class, but we divide 0.95. But it can be impacted by the standard deviation of the compressors that are tested, the number of samples, and the T-stat that is used in the one-tailed test. So I got this little spreadsheet up here for you all, and we start with these 4 machines, and they all got the same mean or average that we would publish on this thing. But in this case, we've got 2 samples, and we've got a big standard deviation. It's of 2 points. So it had one test at 74 and 72%. And so under the KGI method, we would produce 74. But when we put in the LCL test, we just lost 5.5 points on this thing, simply because there was a big standard deviation on it, and even maybe the lower one passed. You could take the same sample where you got the same standard deviation, but you run 4 models. Now the T-stat changes, and your LCL then bumps up to 75, and then you have to use the average. But that's how you get around it, by running more samples. Or in this 3rd sample down here, if you have a very low standard deviation, it's 0.5, you make the test. But then even if you run more tests, you beat it by more. But you have to take the lesser of these 2, so that's what has to be published on the data sheet. But I don't believe any manufacturer at this point is putting that on a KGI data sheet. And this is something we're going to all have to modify to meet, the new standard. Obviously, lots and lots of models got to be tested, because as I mentioned, every horsepower at each pressure that we're going to put it into commerce, we need to have it tested, and it has to be tested in conformance with the Department of Energy's regulation, which means there has to be a test facility that really runs based on their part. We happen to have 2 of the Hooks machines at the Sullivan-Palatek plant. We got a nice air-conditioned room, and we figured out how to do that. But this is quite an ordeal. There is one other way to get an item approved. It's called through an alternative efficiency determination method, which could be used if you were going to do a real custom type of application. And you could, instead of, the problem would be you never built it before, and you don't want to build it and then find out it didn't test. So you can come up with a mathematical model and register before it's built, but it's got to be taken off of test data. So maybe you're going to use an explosion-proof motor, and that's what you're going to substitute, but you have a basic model that was done on a regular TEFC motor. So then it did pass under that, and you use the math model to test it, and that's one thing that they have allowed in this, and they allow this on other products too. So there's some consistency on it. Department of Energy will require registration. They haven't yet told us what it's going to be. In the case of California, we weren't even told until about 2 weeks before the date came through. They finally set the database and told us what we had to do, so they were really behind on it. But at some point, the Department of Energy plans to give us instructions, but they have told us we will need to register our test facility. We're going to have to certify that the products have been tested, and so that means at least 2 tests per machine. And again, at every pressure, and then if we have a model variation, we'll be needing to, on the ancillary equipment, we'll have to tell you know, a description of what that machine is, but we won't have to rate the, you know, it as a new test. The responsibility of complying resides on the manufacturer if they reside in the U.S. If it's an importer of a compressor, then the company importing the compressor has to be responsible with the Department of Energy. And we don't know what they're going to do, you know, as far as following up on it, but if they have reasons to check things out, I was even told they could do almost like an IRS audit where they just, you know, check your data and that kind of thing. If they have reason to suspect that there's things out of compliance or they aren't registered, they could get warnings, notice of non-compliance, civil penalties, and you know, order up to an order not to sell. It looks like there's a progressive discipline that goes in place on this, but it'll be probably consistent with the many other products that the Department of Energy regulates. So this is the date of compliance. Anything manufactured before January 10th, if you've got it in stock, you can still sell it. But after anything manufactured after the date of January 10th has to meet the standard, and it has to be registered in the federal database. Questions? Yes?
So, permanent magnet motor machines are not being tested?
What's that? It's a the
permanent magnet motors.
I believe as long as they're the, what is it, the brushless, I don't even know what that is, but I believe they would have to be tested, yes.
And it also sounds like each individual manufacturer should have their own test cells, provide their own data, and then they can audit it later if they want.
It's probably advisable you have a test facility that meets the standard. The one we use for KGI that's independent, it is so hard to get test time there, it's impractical. And they charge $10,000 or so a test anyway, so you're better off having your own place. Yes?
Does lubrication play any role here? I mean, when you're testing, it doesn't matter what type of lubricant you're testing. Lubrication.
Lubrication.
Does it play any role at all?
It's possible it could play a role in your performance. You know, if you got, you know, a lubricant that really, you know, reduced friction, it might, I mean, it's part of the machine and part of the test, so whatever you have in it.
But once it's qualified, if you do your testing with a specific type of lubricant, not even brand, and you pass, then
that's going to be, I think
down.
that's a good question that the Department of Energy is going to have to sort out.
Yeah.
Yes?
I assume any unit in service is exempt.
Oh yeah, and any unit that's been, I think you're okay if you rebuild a unit. You know, it's the original manufacture date placed on a manufacturer. So you know, if we manufacture something on January 11th, and, you know, before we ship it to somebody, we have to have it tested and registered. Questions? Yes.
Why?
The federal government does a lot of this. You know, I think there was a lot of concern about the manufacturers, but suddenly states got involved. California, then Colorado and Washington adopted their thing, and the manufacturers finally said, you know, let's just go back to the federal standard. You know, we don't want to have to deal with multiple standards on top of that, you know, with different states. And so at least we have a uniform standard.
Why not one?
You'll have to ask people in Washington, D.C. that question, and they have different reasons for it. The stated reason was that they could, it's in the document that there is a 0.6% improvement in energy efficiency. So it wasn't very much. Do I have more time or for questions or? 1 minute before the gong goes. Questions? Okay, thank you very much.
Thank you.